Welcome students, today our topic is octal addition and subtraction, hexadecimal addition and subtraction, and BCD addition. Let us first start with octal addition and subtraction. So we need to keep track of following rules in the addition process and subtraction. Rule first is that we have to add or subtract any two octal digits or numbers like ordinary decimal arithmetics. Rule number second is that if after addition of two octal digits, number generated is greater than 7, then it is to be converted into octal. And rule third is, in case of subtraction, the borrow is 8, which is the base of the octal system. Let us do few examples to understand working of these rules. Example first, 24 in octal is to be added to 32 in the octal. So we have to do the addition and we need to do it by rule number 1. That means we have to follow the decimal arithmetics here. Therefore, 4 plus 2 is equal to 6 and 2 plus 3 is equal to 5, and this will be the required result. Let us take another example. Here we have to add 777 in octal to 111 in octal. Now what we can see from the least significant digit that we have 7 plus 1, and 7 plus 1 is equal to 8. But 8 in octal cannot be a symbol because we have the symbols that is only for 0 to r minus 1, that is 0 to 7. So what we need to do as per the rule number 2, we need to convert this 8 to the octal number. Now 8 to the octal number, when we convert this, will be equal to 10, as the quotient is 1 and remainder is 0. So 8 is equal to 10 in octal. So what we can write here is that we write 0 here and 1 gets carried forward to next significant digit. Now we have 1 plus 7 plus 1, which is equal to 9, and 9 will be equal to 1 in octal. So we write 1 here and this 1 gets carried to the next significant digit. So we have again 1 plus 7 plus 1, that will be equal to 9, and 9 is equal to 11. So this is the result in the octal form. Now let us take another example on the addition process. So we have to add 5, 6, 7 in octal to the 2, 4, 3 in the octal. Again, we start with the least significant digit. So we have 7 plus 3, and 7 plus 3 is equal to 10 in the decimal. Now 10 is equal to 1, 2 in the octal. We can derive it using division process. So it is 1 as quotient and 2 as remainder, which is equal to 1, 2. So what we have to write here is 2 and 1 gets carried forward to the next digits. So it is 1 plus 6 plus 4, which is equal to 11, which is equal to 1, 3 in the octal. So we need to write 3 here and 1 gets carried forward to the next digit. So 1 plus 5 plus 2 is equal to 8, and 8 decimal is equal to 10 in the octal. So this is the really result in the octal form. Let us take the example of octal subtraction. So here we have to subtract 524 from 612 in the octal. So start from the LSB digit. So we have to subtract 4 from the 2, which is not possible. So we need to borrow 8 from here. So 8 gets borrowed from here. 8 plus 2 is 10, and 10 minus 4 is equal to 6. So after borrowing from 1, here what remains is 0. So next we have 0 minus 2, which is also not possible. So 0 will borrow 8 from this 6. So 8 plus 0 is equal to 8, and 8 minus 2 is again equal to 6. So while borrowing 8 from this 6, it remains 5 here. Now next we have 5 minus 5 is equal to 0. So this will be the octal subtraction of these two numbers. It is also important to mention here that we can use another method where we convert octal numbers into binary, then add these numbers like we did in binary arithmetics. Let us now take hexadecimal addition and subtraction process. Here the three rules are: rule first is that we have to add or subtract hexadecimal numbers like any other decimal numbers. Rule second is that if after the addition of two digits the result is greater than 15, we need to convert that into hex. And rule third is again that if we have in the subtraction process there is a borrow, the borrow is equal to the base, which is equal to 16 in case of hexadecimal subtraction. Let us understand these rules by the examples. First, take the example of hexadecimal addition where we have to add 1A8 to 67B in hexadecimal. Before going through the addition process, I would recommend that students should keep the side note of the weights of each of the symbols A to F so that to avoid any unnecessary confusions while addition. So we can see in the LSB, we have 8 plus B. Now 8B is equal to 11, 8 plus 11 is equal to 19, and 19 is greater than 15. We need to convert this into hexadecimal. So we have the quotient as 1 and remainder is 3. So 19 is equal to 13 in hexadecimal. So we write 3 here and 1 gets carried forward to the next digit addition. So we have 1 plus a plus 7, a is equal to 10. So we have 1 plus 10 plus 7, which is equal to 18. So 18 will be equal to 1, 2 in the hexadecimal. So we can write 2 here and 1 gets carried forward to. So we have 1 plus 1 plus 6, that is equal to 8. So this is the result in the hexadecimal. Let us now take one example on hexadecimal subtraction where we have to subtract 200 by 11d. Now on the LSB we have 0 minus d and d is equal to 13. Now we can see we cannot subtract 13 from the 0, so we have to borrow 16 from here. However, you can see that we have 0 again here, so it will borrow 16 from here. So this will be now 16 and we are borrowing 1 from here, so we get 16 here. Now, and the LSB we can see we have 16 minus 13 now, which will be equal to 3. After borrowing process, what we are left with 15 here and we are left with 1 here. Now in the next stage we have 15 minus 1, which is equal to 14, and 14 is equal to E in hexadecimal. And again at the MSB we have 1 minus 1, which is equal to 0. So this is the result of the hexadecimal subtraction. Now let us take BCD addition, that is binary coded decimal addition. The rules for BCD addition are: rule first, addition is to be done using binary representation. Rule second, if sum of two BCD digits is greater than 9, then the result is said to be invalid. And to make it valid, what we need to do, we need to add 6 or 0110 in binary to make the results valid. Rule third is that if carry is generated from the addition of two BCD numbers at the MSB, so the result is again invalid and we need to again add 0110 or 6 to make the results valid. Let us take few examples to understand these rules. The first example is 55 plus 66, and of course this will be equal to 121 in decimal, but we need to do it in the binary coded decimal arithmetic form. So the first step is we need to write the 55 and 66 in binary form, and for each digit we have to assign 4 bits. So 5 can be represented as 0101, and another 5 can be written as 0101, and 6 can be represented as 0110, and another 6 can be represented as 0110. Now we need to add these numbers using binary arithmetics. So 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, and the carry gets forwarded here. So 1 plus 0 is 1. So similarly with the case here, now you can see the result after the addition of each binary coded digit is not valid because it is greater than 9, as 1011 is equal to 11 in decimal. So these are not the valid BCD numbers. So what we require to do is we need to add 0110 to each invalid code, so to make the results valid. Now we can see 0 plus 1 is equal to 1, and we have 1 plus 1 is equal to 0 with the carry forwarded here. So 1 plus 1 is again 0, so carry forwarded here, 1 plus 1 is again 0 with the carry forward to next stage. So it is equal to 0. Now we'll have 1 here, then 0 0 and 1. You can see this is equal to 1, this is equal to 2, and this is equal to 1, and the result is same as we get from the decimal arithmetics. Let us take another example where we have to add 74 and 91 using BCD. So in decimal, this will be equal to 165. Now using BCD, what we require to do, we need to represent 74 and 91 using binary representation and add the numbers using binary arithmetics. So 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 0, 1 plus 1 is 0 with the carry forward here. So 1 plus 1 is 0 with the carry forward here. 1 plus 1 is 0 with the 1 carry forward here. 1 plus 1 is 0 and with the 1 carry forward here. So you can see that at this MSB stage of this digit, we have the 1 carry as the output. So one can conclude that this is the valid BCD because this is less than 9 and we do not have any carry that is generated from the MSB bit. But this is the invalid BCD because the carry is generated at the MSB addition. So to make it valid, what we require to do, we need to write 0101 as such because this is valid, and we need to add to this 000 0110. So the result can be written as, after the addition, is 0110, and we have the 1 carry generated here. So this is equal to 1, this is equal to 6 and this is equal to 5, which is same as that of by a decimal addition. Let us take last example. 48 plus 18, this will be of course equal to 66 in decimal. Now using BCD, we need to first write it into binary form. Now we can add them in binary form. The result will be 0, 0, 0, and here the result will be again 0, but the carry will be generated at the MSB of this digit, so carry gets forwarded here. So result is equal to 0 with the one carry here. So 1, 1 and 0. So one can clearly see that this is invalid BCD code, although it is less than 9 because of the carry at the MSB, and this is the valid BCD code. So one can write directly this BCD code, valid BCD code, and we have to add 0, 1, 1, 0 to this invalid BCD code, and the result will be 0, 1, 1, 0, and we can see clearly this is equal to 6 and this is equal to 6, which is same as that of the decimal addition. So this is all for now. Thank you.